In today's video, I'm going to look at a very interesting integral. This is improper integral set as I equal to cosine x over 1 plus x squared dx, as x goes from 0 to plus infinity. Okay, the first thing we mentioned in this integral, if you take a look at the denominator, you have 1 plus x squared. This function 1 plus x squared doesn't accept any real roots, so we are going to evaluate this integral in the complex coordinate plane by choosing this upper half semicircle. Okay, let's contract this one. So as you see here, we have x-axis represents real numbers, vertical axis represent imaginary numbers. So we have the origin O. So we have this half semicircle with the radius r. So we have minus r, we have this plus r. So I'm going to find out the poles. Okay, so let's set f of z equal to e to the iz over 1 plus z squared. So the first thing I should do, I'm going to look for the poles. Okay, I'm going to find the roots of this one. So f of z equal to e to iz over 1 plus z minus I squared, by replacing 1 by minus I squared. So it's giving us, so we found two poles here. So the first pole z equal to I, the second pole, but so I as a pole, the first pole is located in this closed contour, but minus I is out of this contour. Okay, so we are taking only which is inside of this contour. Okay, I'm going to apply the residue theorem. So I have this integral, so f of z dz. So I'm going to calculate the sum of these integrals over contour. So I will have from minus r to the r f of z dz plus this integral, this gamma integral f of z dz equal 2 pi I f z zi. Okay, so we have only two poles here. z1 equal to the limit of z minus this function I z z1 over z minus I is multiplied by z plus I. The nice thing here, this one will be cancelled out. Okay, so what's left, I'm going to replace z1 with its value, which is I, over I plus I, 2I. So we'll have I is multiplied by I, which is I squared, which is minus 1, which is minus 1 e to the minus 1 over 2I. Okay, the only pole that I have only z1. Okay, the other one is out of the contour. So I'm going to evaluate this integral, which is gamma f of z, integral of f of z dz equal to e to the iz over 1 plus z squared dz. Okay, e to the I theta. Okay, as theta is between 0 to pi. Okay, this is, I'm going to replace z I with r e theta, e to the I theta over 1 plus z squared, which is e to the I theta quinary square. I'm going to derivate this one dz in terms of theta. I will have r is multiplied by I e to the I theta d theta. Okay, so this one, so what I'm going to do now, I'm going to apply the absolute value here on both sides, because we change everything to the theta. We are following the anti-clockwise direction. Okay, so I will have the absolute value of this one, 0 pi is multiplied by absolute value of a theta, okay, d theta. So as you know here, this a theta, it goes equal to 1, because the modulo of this one equal to 1. Okay, now I'm going to apply the triangle inequality. So we'll have r e theta quantity square plus 1. This plus 1 I can rewrite it as r e theta quantity square minus and minus 1 like this. Okay, by applying triangle inequality, this one will be in superior or equal to this one, r e to the 8 theta quantity square minus 1. Okay, like this. So as you see here, this absolute value of minus 1 equal to 1. So I will have this one, if I'm taking the absolute value of this one, this absolute value of minus 1 equal to 1. So, and also this one, this term, it will be cancelled out because the margin of 8 e to the 8 theta equal to 1. So I will have this one, I will have r to the 8 theta quantity square plus 1 is it superior or equal to this one, r square. So as you see here, this term r, the absolute value of this one, r e to the I theta quantity square, is gonna go to the 1, equal to 1, because the margin of e to the I theta equal to 1. So I will have only r here, r square. So this term is superior or equal to r square minus 1. Okay, so I'm going to take the reciprocal of this one. So I will have 1 over r e to the I theta quantity square plus 1 is inferior or equal to 1 over r square minus 1. Okay, so in the last board I was working on gamma integral and came up with this result. So since r is going to infinity, so I'm going to take off the absolute value from denominator. So I will have this term is inferior or equal to r over r square minus 1, because I took r square minus 1 outside of this integral because it's considered as a constant. So I will have this from 0 to pi, absolute value of this term e to the ir e to the ir. So I'm going to replace e to the I theta by cosine theta plus I sine theta, the Euler formula, d theta. Okay, so absolute value. So I'm going to make the product. Okay, here. So I will have this one is inferior or equal to r. I'm going to make the product. So r over r square minus 1. The integral from 0 to pi. I will have this one ar cosine theta. Okay, I'm going to multiply I by I is given minus 1. I is multiplied by I, which is I square, which is minus 1, minus r sine theta, d theta. Okay, so if you take a look at here, this one equal to 1, because this is a real number. Okay, so this one is inferior or equal to r over r square minus 1. The integral from 0 to pi. I will have only this term, which is positive. So now I take the absolute value off. Now I'm going to take the absolute value off. So I will have minus r sine theta d theta. Okay, so if you take a look at this integral, so there is a problem if you evaluate this integral, because so if r is going to infinity, since we have r is positive and sine theta is between 0 to pi, that means sine theta is positive. So that means this one is going to be 0. Okay, but remember, if you replace theta with 0, this term will be 0. With this r with this infinity, it become a problem. The same thing with the pi. If you replace theta with a pi, it's gonna be 0 as well. So 0 is multiplied by infinity is going to be a problem as well. So what I'm going to do now, I'm going to show we have this formula. Sine theta is superior or equal to over pi theta. This one you can apply the mean value theorem in order to show this one. So it's easy to show it. Now I'm going to split this integral. Okay, so this integral, let's call this one I integral. Okay, I integral equal from 0 to pi e to minus r sine theta d theta. Okay, I'm going to show this integral equal to 2 times from 0 to pi over 2 e to the minus r sine theta d theta, as theta between 0 to pi. I'm going to make the substitution of this one. So I will have put the theta equal to pi minus t. If you replace pi over 2 in theta, so we'll have t equal to pi over 2. If you replace theta with pi, t equal to 0 here. Okay, so this theta equal to pi minus t. Pi minus t, it become sine t. Okay, this d theta equal to minus dt, minus dt. I'm taking this minus outside. I'm going to switch this bounds, so become from 0 to pi over 2 by taking this minus sign. And it's no problem if I'm going back to the original variable. So I will have d theta t theta. Okay, if you take a look at here, this integral equal to this integral, so that means this integral equal 2 times this integral. So this one r over r squared minus 1 is multiplied by 2 times this integral, which is 2 times from 0 to pi over 2 e to minus r. So this one, since we have sine theta is superior or equal to pi over theta, so this one we have sine theta is superior or equal to over pi theta. I'm going to put minus theta is multiplied by r as well here, is inferior or equal to 2 pi r theta. Okay, I'm going to put the e on both sides. Okay, so we'll have this one is inferior to minus 2 over pi r theta. Okay, d theta. So this one, in the last board I was working on gamma integral of this closed contour and came up with this final expression. So now I'm going to evaluate this integral. So we have this one, the absolute value of this integral f of z dz, okay, over gamma is inferior or equal to r over r squared minus 1. Now I'm going to evaluate this integral simply. So the primitive of this one, minus 1 pi over 2r is multiplied by e to the minus 2 over pi r theta, minus pi over 2r is multiplied by e to the minus 2 over pi r theta, the bound from 0 to pi over 2. So I'm going to insert pi over 2 into theta. Okay, so I will have f of z dz integral over gamma. So I have absolute value of this integral is inferior or equal to r over r squared minus 1. So I'm going to take this minus pi over 2r outside. So I will have minus pi over 2r. Okay, so this one I'm going to insert pi over 2 into theta, so we'll have minus 2 over pi r pi over 2 multiplied by pi over 2 minus 1, because if you plug 0 into theta, this term will be equal to 1. Okay, so I will have this one, so I will have this integral f of z dz over gamma is inferior or equal, so I'm going to cancel out to r by changing this order of these terms and taking off the minus sign from the front. So I will have pi over r squared minus 1 is multiplied by 1 minus e to the minus, so the pi, and so the pi will be cancelled out with pi, the minus 2 will be cancelled out with minus 1. So we'll have minus r here, 1 minus e to minus r. So I have 1 minus e to the minus r. So since we have r is going to infinity, so this term will be turned to 0. So r is going to plus infinity, so this term will be 0. So I will have this term equal to pi over r squared minus 1. So as r is going to infinity, this term is going to 0. So this term equal to 0. Okay? This integral of z dz equal to 0. Okay? Now I'm almost done. Just bring this one at the top and continue with our problem. So I'm going to summarize this one. So we have this integral from minus r to the r f of z dz, okay, plus 0 plus this integral over gamma, which is 0, equal to pi is multiplied by I triple z1 equal to I. Okay, because this pool I is inside of this closed contour, minus I was outside. That's why we didn't put two poles here. As r goes to infinity, so we have minus infinity to plus infinity. I'm going to replace z by x because we are working along ox axis. Okay, so z equal to x. So this integral become e to the ix over 1 plus x squared dx. So this integral become from minus infinity to plus infinity, e to the ix over 1 plus x squared dx equal to pi I is multiplied. We already calculate the residues of this one. It was e to the minus 1 over 2i. So I'm going to cancel out 2 and I become pi over e. Okay, as you see here, our I integral from 0 to plus infinity cosine x over 1 plus x squared dx. Since this function cosine x over 1 plus x squared is an even function, so let's mean this integral is a half of this integral, which is 1 over 2 from minus infinity to plus infinity cosine x over 1 plus x squared dx, okay, which is pi over 2a. Okay, so I have done with this problem. We will see more examples in next coming videos. Just consider subscribers. Thank you for watching. I will see you in next video. Bye.